Factorial of a number n, written n with an exclamation mark, means multiply every whole number from 1 up to n together. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. This is one of the most natural fits for recursion, because a factorial is defined in terms of as a smaller factorial. A factorial is built from the one just below it. N factorial is simply n multiplied by n minus 1 factorial. So we let the function compute the smaller factorial, then multiply by n. The calls go down n, then n minus 1, then n minus 2, until n reaches 0. Factorial of 0 is defined as 1, and that is our base case, the anchor. Then the multiplications unwind back up. Since n shrinks by 1 each time, it always reaches 0. So the recursion terminates. If n is 0, we return 1, because the empty product is 1, and that stops the recursion. Otherwise, we return n times the factorial of n minus 1. Each level contributes its own factor and relies on the level below to multiply the rest. Let's type it out and check a few factorials live. The base case. Factorial of 0 is 1, and that anchors the whole recursion. The recursive step. We multiply n by the factorial of n minus 1, letting the function handle the smaller product. Now, let's test it and hit run. There they are. 5 factorial is 120, 0 factorial is 1, and 6 factorial is 720. Each answer is n multiplied by the smaller factorial beneath it. The flow is compact. If n is 0, we return 1. Otherwise, we return n times the factorial of n minus 1, and the calls keep going down until they reach that base case of 0. There is one call and one multiplication for each number from n down to 0, so the time is order n. And since each paused call waits on the stack for the smaller one to finish, the space is order n as well. Keep these in mind. First, the base case is factorial of 0 equals 1, not 0, a very common slip. Second, factorials explode in size, so in languages with fixed size integers, they overflow quickly, though Python handles big numbers for us. And third, factorial is not defined for negative numbers, so guard against them.